Hello class, today we're going to go ahead and start our section on special right triangles and trigonometric applications. So what we have is we are going to look at 45, 45, 90 triangles and 30, 60, 90 triangles. So your learning target for today is that you'll be able to apply the properties of these special right triangles. So if I go ahead and look at this, I want to express the length of the hypotenuse in terms of x. Well, if I use that all the angles in a triangle have to add to 180. Well, I know this is a 90 degree, this is 45. 180 minus 90 minus 45, that's going to give me 45. So that tells me that this other angle needs to be a 45-degree angle. Since my two angles are the same, okay, I know that I have an isosceles triangle. Okay, and so that tells me that I can go ahead and if this side is this angle is 45, this side and this angle is 45, the opposite side, those two sides are the same. So this is also x. So what we want to do is we want to express the hypotenuse in terms of x. Well, if I have x and x for my two legs, I can go ahead and do that. What I would do is I would have x squared plus x squared is equal to, well, I'm trying to find the hypotenuse, I'm going to call it c. So c squared using my Pythagorean theorem. X squared plus x squared is equal to 2x squared is equal to c squared. And then if I want to solve for c, I would need to go ahead and take the square root on both sides. The square root of 2, well, it's an irrational number, so I'll leave it as the square root of 2. And the square root of x squared will just give me x, so it's going to be out in front. So that is equal to c. So the way I would look at my 45, 45, 90 triangles is that this side is x, this side is x, and my hypotenuse is x square root of 2. So using this idea, I'm going to go ahead and do the next examples. One thing that I would want you to notice is that, notice how this uses the square root of 2. Well, how many different side lengths are there? We have x and then x square root of 2, so there's two different side lengths, so it is x square root of 2 on the hypotenuse. Do you need to use these patterns? Absolutely not. There's other options. You can use SOHCAHTOA to find the missing side, but we are going to go ahead and do these problems using the 45, 45, 90-degree triangles. So looking at this, if I just start plugging in what I know, that my two legs with the 45-degree angles are x. So I'm going to say, well, this is equal to x, and this is equal to x. And then I know that my hypotenuse is the same as x square root of 2. Okay, well, to figure out what x is, I know it kind of seems weird. There's a lot of x's going on here. But this tells me that x is 4. So this side is 4. And then lastly, if x is 4, 4 square root of 2 is equal to my hypotenuse, or x. So that would be my answer for number 1. If I go ahead and look at number 2, want to find the value of x again. Well, this time, I know that this is equal to x, and this is equal to x, and my hypotenuse is x square root of 2. So what I need to do is actually solve for what x is. I would divide both sides by 5. Sorry, I need to get x by itself, don't I? If I want to get x by itself, I would divide both sides by the square root of 2. And if you notice, square root of 2 will simplify to 1. So x is equal to 5. So the value of x in this case is that x is equal to 5. Let's go ahead and try this one, example 3. It says find the value of x again. Well, my legs are equal to x, and my hypotenuse is equal to x square root of 2. So same idea as before, I need to solve for x. So in order to do that, I would divide both sides by square root of 2. Okay, so x is equal to 12 over the square root of 2. It's not proper to leave that square root of 2 in the denominator, so I need to rationalize the denominator, meaning I need to get rid of that square root. So I multiply both sides. I multiply that side by the square root of 2 over the square root of 2, which is the same as 1. So I would have 12 square root of 2 over, well, the square root of 2 times the square root of 2 is 2. And then 12 divided by 2 is 6 square root of 2. Okay, so that is what x is equal to. X is equal to 6 square root of 2. So that was our 45, 45, 90 triangle. Now we're going to look at our 30, 60, 90 triangle. Same idea. The way you can get a 30, 60, 90 triangle is by starting with an equilateral triangle. Okay, so this is starting with an equilateral. All the angles were originally 60 degrees. Okay, and I'm just going to go ahead and we're looking at one, so breaking it apart. So if this length is 2x, they tell us that this is 2x. Well, this whole thing here is a length of 2x, but if I just want to look at this small triangle, it would be half of that, so that would be x. Okay. Now all I need to do is go ahead and figure out what this length is. We don't know what that is, so we're going to use the Pythagorean theorem again to do that. So I'm just going to label what I know over here. This would be my 60-degree angle. This is x, and this is 2x. And so I'm going to use the Pythagorean theorem to figure out what this last side is right here. So I have my hypotenuse, so I'm going to call this, let's call this side b for now. So I would have b squared plus x squared is equal to 2x squared, and it's all of it squared. So I have b squared plus x squared is equal to, I would square each piece. So I would have 2 squared is 4, then x squared. And now I'm trying to figure out what b is. So I would subtract x squared from both sides. If I have 4x squared and I minus x squared, I'm going to get 3x squared. And then in order to solve for b, I would take the square root on both sides. So I have that b is equal to the square root of 3. We leave as the square root of 3. The square root of x squared is just x. So the way I can write this is b is really x square root of 3. So this would be my 30, 60, 90 triangle. Notice across from my 30-degree angle is always just x. Across from my hypotenuse, my right angle is my hypotenuse, which is always 2x. And then across from my 60-degree angle is x square root of 3. If you notice, this triangle will have 3 different side lengths. 1, 2, 3 different side lengths. And so that is why one way to remember that is the square root of 3. Okay? So let's go ahead and do some examples using this. Same thing. Do you have to know these patterns? It's very helpful, but you don't need to. You can always use SOHCAHTOA to find the other missing sides. So, example 4, find the values of x and y. Well, across from my 60-degree angle is my x square root of 3. My hypotenuse is always 2x, and then across from my 30-degree angle, which would be here, is just x. So we need to figure out, well, what is x? So I would solve. I have that 2x is equal to 10, so I would divide by 2, so x is equal to 5. Okay. Well, in that case, then this x is equal to 5. And then y is equal to, well, x times the square root of 3. X is 5 square root of 3. Let's go ahead and look at example B. Still a 30, 60, 90 triangle. So across from my 30-degree angle is always x. Across from my 60 is always x square root of 3. And my hypotenuse is always 2x. So I want to look for which side has 2 pieces of information. So it would be this one. So I would need to solve for x. So I would divide both sides by square root of 3. So x is equal to 12 over square root of 3. Now I would rationalize the denominator. So multiply by the square root of 3 over the square root of 3. So I have 12 square root of 3 all over 3. 12 divided by 3 is 4, so it's 4 square root of 3. So x is 4 square root of 3. Now I need to solve for y. Y is 2 times x. Well, 2 times 4 square root of 3. Well, 2 times 4 is 8, so y is 8 square root of 3. Now remember, you can go ahead and pause the video at any time, rewind at any time if you need to. So this is halfway. If you need to take a break, feel free to pause it, and then come back and we'll do the back side of the note sheet. All right. So example 5 says find the exact values of sine of 45 degrees. So that means no decimals. So that means you need to leave it. So here is an example of my 45, 45, 90 triangle. Okay, and here is an example of my 30, 60, 90 triangle. So if I'm trying to find the exact values of sine, cosine, tangent of any of these angles, I'm just going to draw one of these triangles. So sine of 45 degrees. Well, I'm going to look at this triangle, the top one, and I'm going to use this angle. Sine is opposite over hypotenuse. So the opposite of my 45 is x over my hypotenuse, x square root of 2. X over x simplifies to 1, so I really have 1 over square root of 2. Well, we know that we do not leave the square root in the denominator, so I'm going to multiply by the square root of 2 over the square root of 2. So I will get square root of 2 over 2. That is what the sine of 45 is. Example 6 says find the exact value of tangent of 45. Once again, looking at that top triangle, I'm going to keep using the angle I was using before, tangent's opposite over adjacent. So my opposite is x. My adjacent is x, so x over x is the same as a 1. So tangent of 45 is 1. Now 7 says find the exact value of sine of 60. Well, now I'm going to be looking at my 30, 60, 90 triangle. Looking at the 60-degree angle, and I figure out sine. Sine is opposite. So I have sine of 60. My opposite is x square root of 3 over hypotenuse, which is 2x. I would notice that the x's will simplify to 1, so I have square root of 3 over 2. That is simplified. So that is sine of 60 degrees, square root of 3 over 2. And then the last one for this kind of example is to find the exact value of tangent of 30 degrees. So now I'm going to go ahead and look at my 30-degree angle to figure out tangent of 30. Tangent is opposite over adjacent, so my opposite now is x, and my adjacent is x square root of 3. My x's will simplify to 1, so I have 1 over the square root of 3. But now I need to rationalize my denominator. Do not leave that square root of 3 there. So multiply by the square root of 3 over the square root of 3. So I will get square root of 3 over 3. That is what the tangent of 30 is. Make sure if you have any questions, you go ahead and jot down any questions that you may have, so you can come back and ask them tomorrow. The next thing we're going to look at is the angle of elevation and the angle of depression. So the angle of elevation of an object as seen by an observer is the angle between the horizontal and the line from the object to the observer's eyes, the line of sight. So what it's saying is if you have an observer, this angle right here, that is your angle of elevation. You're always looking up, okay, for angle of elevation, okay? Think about if you elevate your feet, you put them in the air, so this is looking up. Angle of depression is the object is below the level of the observer, then the angle between the horizontal and the observer line of sight is called the angle of depression. So it's looking out, and it's looking at this object, so this is my line of sight, so your angle of depression is here. One thing that will be important to remember from geometry is that if I have this angle and this angle, okay, since this is a parallel line and this is a parallel line, okay, they are alternate interior angles. And remember, alternate interior angles are the same. So if this is a 33-degree angle, then this is a 33-degree angle. One thing to keep in mind. Okay, so using those angle of elevation and depression, let's look at some more examples. Example 9, a tree casts a shadow 25 feet long. Here's my tree, it's casting a shadow, it's 25 feet long. Okay, the angle of elevation from the tip of the shadow to the top of the tree is 64 degrees. So at the tip of the shadow here to the top of the tree is 64 degrees. Find the height of the tree. So we want to find the height. Well, I would decide, is this sine, cosine, or tangent? I have my opposite, and I have my adjacent. So tangent uses those. So tangent of 64 degrees is equal to my opposite, h, over my adjacent, 25. I would go ahead and solve. I want to get h by itself, so I'll multiply by 25 on both sides. So h is equal to 25 times tangent of 64 degrees. I would make sure my calculator is in degree mode. Then I will go ahead and type it in. When I do and round to 3 decimal places, I get 51.258, and I would label it in feet. Example 10. When landing a jet, will average a 3-degree angle of descent. What is the altitude to the nearest foot of the jet on a final descent as it passes over an airport beacon 6 miles from the start of the runway? Okay, so notice how it says foot and this is in miles. We've got to keep that in mind. So if this is my jet, looks more like a whale, but that's my jet, and they're telling me my angle of descent is 3 degrees. So my angle of descent is 3 degrees. So that would be here. And they also tell me that we want to find the altitude, so that would be here, that's my A, to the nearest foot, and it passes over an airport beacon 6 miles away from the start of the runway. Okay, so this is 6 miles. So I'm going to go ahead and solve this. So like I said before, if this is 3 degrees, my alternate interior angle would also be 3 degrees. Okay, so I have my opposites and I have my adjacent. So once again, I'm going to be using tangent. So it's tangent of 3 degrees is equal to A over 6. Okay. So I would multiply by 6 on both sides. So my altitude is 6 times tangent of 3 degrees. So if you type this into your calculator, okay, you're going to get that A is 0.314. Well, think about it. This was in miles. Okay, so my label's in miles, but the answer needs to be to the nearest foot. So what I would need to do is take that answer, don't delete it off your screen, use the entire answer, and I would take this and multiply it by, well, how many feet are in a mile? There's 5,280 feet, so multiply that by the number of feet. And when you do that, you'll get that your altitude, rounded to the nearest foot, is 1,660 feet. That would be my altitude. Number 11, suppose a tree 50 feet in height casts a shadow of a length of 60 feet. So once again, have a tree, and it's a height of 50 feet, casts a shadow of 60 feet. What is the angle of elevation from the end of the shadow to the top of the tree with respect to the ground? So this would be my angle of elevation I'm trying to find. I'm going to go ahead and call it x degrees. So we need to solve for x. Once again, I look at who I have. Opposite and adjacent. So once again, I'm going to use tangent. So it's tangent of x degrees is equal to 50 feet over 60. Now remember, in order to solve for an angle, I would do that x is equal to tangent inverse of 50 over 60. Type that into your calculator, okay, and we would get that the angle is 39, and I round to 3 decimal places, 0.806 degrees. That would be my solution. Okay, we're going to go ahead and stop the video. That's the end of the notes. You're going to do the special right triangles with applications worksheet next. Please write down any questions that you may have so you can ask them in class. Otherwise, have a great day.